Hey, what's up, class? Welcome back. Another episode of Math 1 Distance Learning from room 1809 at John Glenn High School. Hope you guys are doing well. So, we have been working on inequalities and equations, and we are coming to a close of this unit of equations and inequalities. We have one more big concept, and that is the concept of ratios and proportions. And ratios and proportions have something to do with equations. So we're going to get into this lesson. So we'll spend the next few days working on ratios and proportions. I'm going to flip over to my PowerPoint, and you guys should have these notes in front of you already. So be ready to go as we go through this PowerPoint. Here we go. All right, so intro to proportions notes. All right, so our objective is we want to be able to use the concepts of ratios, so something called a ratio, and proportions, and we actually want to be able to use those to solve real life problems. All right, so here we go. Definition of a ratio. You have this in your notes. You can just fill in the blanks. A ratio is a comparison of two kinds of similar items. Okay, so I'll give you some examples here, but a comparison of two kinds of similar items, right? So, for example, if we're looking at this scale here, we can do a ratio of this man's full height. So we can do a ratio of his full height compared to just the length of his leg. Or we can do a ratio of the size of his head here compared to his entire body. Okay, so those are just a couple examples. I think you've got that photo on your notes. So an example here, the average person is 7.5 heads tall, including their head. So if you look at this, this drawing of this full-grown man, so if we take the size of his head or the size of your head once you're full grown, we take that, and then you can actually, a person's height is about 7.5 heads, including their own head. So the measure from here to here, so that's 1, 2, 3, 4, 5, 6, 7, and then about a half, 7.5, right, to about there. Okay, so that's actually that's a true statement. Okay, so an average person is about 7.5 heads tall, including their own head. Okay, so that's a ratio. We're comparing a person's head to their entire length of their body. So we're comparing similar items. So we're comparing a human head to the entire human body. Okay, so two kinds of things that are similar or have something to do with one another. All right, so our ratio would be 1 to 7.5, right? So we would be comparing one human head to 7.5 human heads. So it's a ratio of 1 to 7.5. You could measure someone's height by 7.5 of their heads. Okay, and then within the human face or the human head, there's all kinds of other ratios and comparisons that we can make, especially this comes up in art class. And we're going to look at some other things in this lesson regarding art. But in art, once, like especially I think art 1, you start learning how to draw like a human face, and you learn other ratios and proportions. But everything has a ratio in the human face. The distance from the top of your skull to where your eyes line up, and where your nose lines up, and where your lips line up. So, for example, a lot of times when people draw, especially little children, when they draw a human face, where do they put the eyes? They normally put the eyes right in the middle of the face, but it's actually the nose. It's what basically falls in the middle of the face. The eyes are a little bit higher. They're about 1/3 of the way down. So, anyways, those are some examples of some ratios in the human body. I don't know if you guys have ever heard of the actress Jessica Alba. She's a little bit older now, but artists used to say that she had the perfect head ratios. So, for example, here's her face, and they said that her face had the perfect ratios. So the distance of her eyes were the perfect distance. Um, the shape of her face was the perfect distance. Her eyes to her lips, the top of her head to her chin. They said that everything was the perfect distance. So just kind of interesting talking about ratios there. Okay. All right, let's move on. So those are ratios. Okay. Other ratios come up in nature. And in nature, there is something called the golden ratio. And this shows up a lot. If you are a person that believes in God, then you might say that, yeah, God created this golden ratio. If you're a person that does not believe in God, then you would just say, well, it's probably just a coincidence. But there is something that's called a golden ratio that scientists have discovered, and this golden ratio it's that they call it the perfect ratio of a 1 to 1.68, or this is almost 1 2/3. It's often found in nature. I'll give you some examples. So one example is this is a sunflower, and if you look at this design, not only is it a beautiful design, apparently these little spirals and then the leaves that come off have a perfect ratio of 1 to 1.68 in size. And they are designed that way, or the benefit of having that perfect ratio is that it allows the sunflower to maximize its water intake when it rains, or when there's the moisture in the air, the dew, and then also sunlight. So it's the perfect ratio. And so again, you might say that, oh, God designed it this way. Or if you don't believe in God, then you would just say, oh, it's just a coincidence. But this sunflower has a perfect ratio. And then this spiral right here, we see this in other patterns also. For example, we see it in this type of a plant here. I forget what that plant's called. Many of you might know it. You see it a lot in like in Mexico and the southern southwest United States. We see this a lot. I don't know if that's an aloe plant. I'm not sure. Anyways, again, there's that perfect spiral, which allows for to maximize the moisture intake as well as sun intake, the way that it's spiraled. That's a perfect ratio. We see this perfect ratio in other places. I've already mentioned the human form, but here's an example of the perfect ratio. So, this golden ratio. So if you measure from the tip of your fingertip all the way to your elbow joint, that the distance from your fingertip to your wrist is a 1 to 1.618 approximately. So that's an interesting ratio right there. So one of these, and then this is 1.6 of those. Okay, so again, we see that. And here's some other ratios in the natural world. Honeycombs. These bee honeycombs, they follow that 1 to 1.618 golden ratio. Spider webs also follow that same ratio, 1 to 1.618 in the way that they're designed, the ratio of the design. And then here's just some other ratios. I'm not sure if the zebra follows that design, but you can definitely see that there's patterns here and what we call symmetry. The left side matches the right side. There's definitely some symmetry and some ratios there. A butterfly has quite a bit of symmetry, and scientists that I'm not sure what the name of the scientists are that study butterflies. I'm sure there's some type of a name, but they're able to look at the ratios of the pattern on their wings and so forth. And there's quite a bit of ratios going on in nature. Some other places that we see ratios, maybe not necessarily the golden ratio, but we definitely see ratios in the man-made world. These would be places where, or these would be examples. I'm giving you now examples of why we would want to know about ratios or proportions, right? A lot of times in math, we ask, well, when am I ever going to use this? Or why would I ever want to know this? I'm never going to use this, right? I hear that a lot from students. Well, here's some places where having a good concept of ratios and proportions actually does matter, and actually can help you, especially in a job someday. So, for example, I'm sure there are many of you that have an interest in fashion and maybe even want to be a fashion designer and design your own clothes. Well, if you don't have a concept of ratio and proportions, you're probably not going to be a very good clothes designer. Here's another example, culinary arts, like a chef. Yeah, I mean, you don't really need to know much about ratios if you're going to fry an egg or, cook pancakes at home. But if you want to be one of these highly paid culinary chefs that work at big time restaurants, then they have to know about ratios. One of the things that we enjoy doing, my family, is we like to watch the Food Network, and we like to watch those different chefs design their meals. And it's all about measurement and ratio and proportion. So definitely need to have an idea of ratios there. So yeah, just there's measurement patterns and ratios in both of those. Okay. All right, so here we go. Let's move on. So here's an example that's a little bit maybe easier for you to understand right now as a high school student. So let's say that, so I think you have this example on your paper. So there are 3 boys for every 5 girls at our high school. Okay, so what that means, so if we're not walking around on campus right now, but if we were, there are approximately, for every 3 boys that are at our school, there are 5 girls at our school. So there's actually more girls at our school than there are boys. And I think just in general in life, there's actually more girls on Earth than there are boys on Earth, or at least when they're born. But anyways, we want to figure out the ratio here. Okay, so it's a 3-to-5 ratio. So we would write this. So we've got boys and girls, right? And so we could write this. There's a few different ways we could write this. We could write this and read it 3-to-5. I know the word 2 is not there, but this is how you would read it. You would say 3-to-5, boys to girls, or you could say 3-to-5, okay? Or you could turn it into a fraction. So a ratio is often written as a fraction. So 3-to-5, or 3-to-5, or 3-to-5. These all mean the same thing. They all represent this little word problem. Okay, so 3-to-5, 3-to-5, and 3-to-5. They all mean the same thing. Okay, all right. So so let's move on to proportions here. Okay, so that was ratios, where we're comparing one thing to another, things that are similar. And okay, so a proportion is a statement of equality between 2 ratios. All right. So for example, we can compare, like this would be an adult male, here's an adult female, and then this would be a child. So we could compare the height of a child to an adult male, or the height of a child to an adult female. So this would be proportions, comparing one entire thing to another. So let's go back to the boys and girls at our school. So if the ratio of boys to girls is 3-to-5, how many boys are there if there are 500 girls? Okay, so this is a pretty simple problem. You can probably do it in your head, but let's go ahead and do it on paper. Okay, so we've got boys to girls. We're comparing boys to girls, and we've got 3-to-5, right? We know that the ratio is 3-to-5, but there are obviously more than just 3 boys at our school, and obviously more than just 5 girls at our school. So if we want to compare, if we already know that there are 500 girls, Okay, so 500 girls. Well, where are we going to put that 500? We're going to put that 500 down here in the girl category. And now we want to figure out, well, how many boys are there up here? Okay, so if there were, so this is a 3 to 5, and I'm going to teach you how to do this. Some of you probably can figure it out in your head. If this is a 5, and that's 500, and this is a 3, then what's that going to be? That is going to equal 300, right? So 5, and we jumped, or what I call leapfrog. We leapfrogged to 500, and then over here, 3, we leapfrogged to 300. Okay, so this is an example of a proportion. We're taking a small ratio and then we're turning it into a big ratio. So this whole thing is called a proportion. All right. Okay, so that X up here would be 300. Okay, so I'm going to teach you two strategies now for solving proportions. Okay. One of them is, I call it the leapfrog strategy. It's kind of just a common sense strategy. Okay, so the first one is this leapfrog strategy. And in the leapfrog strategy, what we want to do is we want to jump like a leapfrog. We want to jump from one ratio to the next. Okay, so from one ratio, we want to go from one ratio to the next ratio. And we want to do that either by multiplying or by dividing. Okay, so now we know that this bottom number is a 5, and we know the bottom number over here is a 40. We know that this is a 2. We're trying to find this missing number up here. So I'm going to leapfrog. So from 5, if I go to 40, am I multiplying to get to 40, or am I dividing? Am I doing 5 divided by something to get there? No, I'm multiplying, right? I'm doing 5 times 8, right? I'm going to do 5 times 8. So I'm going to leapfrog times 8. So over here, I'm going to do the same thing. Whatever you do to the bottom of a fraction, you have to do to the top of the fraction. So 5 times 8 is 40. So 2 times 8 is going to be 16. Okay, so I leapfrogged. So I'm going from here to here. I'm leapfrogging. All right. Okay, now I'm going to show you another strategy. So the leapfrog strategy is great when the numbers are easy to work with. Okay, so I leapfrogged. I went from 5 to 40. So I times by 8. And then I went 2 times 8 to get 16. Okay, so that's the leapfrog strategy. All right. Now, the next strategy is what I call a cross multiply. And I think I showed this to you the other day in class, but if you weren't there, I'm going to go over it again. So this next strategy is called the cross multiply strategy. Okay, so I'm going to take the same proportion. We just leapfrogged. We went here to here and then over to here. But now I'm going to do it a little differently. I'm going to cross multiply. So I'm going to go across the proportion, right? I have one ratio equal to another ratio. So this is a proportion. The whole thing's a proportion. And I want to solve for X. I want to find out what that missing number is. So I'm going to cross multiply. I'm going to go across the equation. So I'm going to go 5 times X is 5X. And then I'm going to go 2 times 40 is 80. And now I'm going to solve this little mini equation. So I'm going to divide by 5. And when I divide by 5, whoops, that's not what I want to do. Whoops, when I divide by 5, I get 16. 80 divided by 5 comes out to 16. And those are the same answer, right? So you can get there by leapfrogging, and you can also get there by doing the cross multiply. 5 times X, 2 times 40 is 80, and then I divide it. Now, the reason I taught you both methods, you might be thinking, well, that leapfrog method's easier. Yes, it is easier, but it doesn't always work. The cross multiply method will always work. And so I'm going to show you what I'm talking about. So sometimes the leapfrog method will not, it'll be too difficult to use. And this one will always work. Okay. All right. So let's try a couple more examples here. Okay. So let's look and see. Can we do a leapfrog here. All right, so I have this number, a top number here, 4, and I have a top number here, 12. So we want to ask ourselves, can I just leapfrog? 4, is there 4 times a number that will get me to there? Yeah, and there is. There's the number 3, right? 4 times 3 will get me there. Okay, so then I want to do the same thing down here. 7 times 3 will get me over to there. Now, whoops, let me back up here for a second. So we know I could do 7 times 3, and we know that that number down there would be 21, right? 7 times 3, we know that's 21. Okay, but I'm going to demonstrate, so this is an easy one, but I'm going to just demonstrate the cross multiply so we can get a handle on that. So because that one's a little more sophisticated. So I'm going to go 4 times x, gives me 4x, and I'm going to go 7 times 12. What's that give us? 84. Okay, and then I'm going to divide by 4. So these cancel, right? And I'm going to get x is equal to 4 goes into 8 2 times, 4 goes into 4 1 time, x is equal to 21. Okay, now we could have gotten that one by leapfrogging. We already know that. We're just practicing the cross multiply. All right, let's try another one. Okay, so on this one, I've got a number downstairs, the 30, and I also have a number downstairs over here, a 5. I have a number upstairs, but I don't know this one. So this is the one we're trying to figure out. Okay, so let's start here. Do I want to do 30 times a number? Is 30 times a number going to give me 5? What do you think? No, right? It's going to be a division. I want to go 30 divided by a number will give me 5. So 30 divided by what? 30 divided by what? Or, so what's the what? The number is 6, right? So now since I know the number, I can go backwards. So 5 times 6 is going to give me 30. So then upstairs, I want to go 7 times 6, and that's going to give me the number 42. Okay, but so I'm going backwards, right? 5 times 6 makes 30, and 7 times 6 makes 42. But let's do the cross multiply. So I'm going to do 5x, and then I'm going to do 30 times 7. So 7 times 3 is 21, and then add your 0 on the end. It's 210. And now I'm going to divide by 5. 5 goes into 21, 4, and then you're going to have to subtract, or you could use a calculator. And 210 divided by 5 comes out to 42, exactly what we just said. We said it was 42. Okay? All right, so on both of these examples, we saw that we could leapfrog to solve the problem. And then we also saw we could cross multiply. Okay? All right, now let's try this one. Okay, so I've got a 3 downstairs and I have a 10 downstairs. Okay, so can I leapfrog to get there? Okay, so 3 times what? So 3 times 10, right? Okay, so now let's try it upstairs. 2x times 10, does that make 5? Whoa, wait a second. Okay, let's try that again. 3 times 10 makes 30, but does 2x times 10 make 5? No, it doesn't. Okay, so leapfrog's not actually going to work here. So we're going to have to actually cross multiply because that doesn't make sense. 2x times 10, 2 times 10 would be 20, not 5. Okay, so we're going to cross multiply. So 2 times 30 is 60x, and then 5 times 3, or 3 times 5, cross multiply there, that's 15. Now, remember, we want to get x by itself. I do not want to divide by 15. I want to divide by 60. So these cancel. And then I have 15 over 60, which we can simplify. And when we simplify that, it becomes 1/4. So our answer for x is actually 1/4, not 4, right? 2 times 4 doesn't make 5. But if I go 2 times 1/4, then I'm going to get 5. Okay, 2 times 1/4. All right. Okay. All right. So let's move on here. Okay. All right. Let's try another one here. Okay. Okay. So on this one, um, let's see. Wow. Well, this is really complicated. So first off, we can't even leapfrog this thing here. Um, we can't even leapfrog it. We can't go um, 4 times something to make 3, and we can't do 3 times something to make 4. And then this is really complicated up here. So we're gonna have to cross multiply. Okay. So let's go ahead and cross multiply right here. Okay. And then I'm going to cross multiply here. So I think I'm going to do this one first. So let's go that way. So I'm going to go 3 and then times 2x plus 1. And then I'm going to go this way here. And then that's going to give me 20. So now we're going to have to do the distributive property, a little boom chicka boom. So we're going to go 3 times 2x and 3 times 1. That's going to give me 6x, and then 3 times 1 is 3. And then here's my 20. And now I can just solve a regular equation, right? So I'm going to subtract 3 from both sides. It's going to give me 18. And come on, where's my 18? Oops, 17, sorry. I don't know where I got 18. 17. 20 minus 3 is 17, not 18. 20 minus 3 is 17. And then I'm going to divide by 6. And this does not go evenly. It doesn't work out. And so remember my rule, if they don't want to play nicely, then we just leave them alone. So your final answer is 17/6. Okay. So on this one, we'll go back and look at it one more time. So it was too complicated to try to leapfrog. So now we're going to cross multiply. So I did 3 times this private party. Then we had to do the distributive property of boom chicka boom. And here was 4 times 5. Okay. All right. Let's move on to the next example. Okay. Now we're going to get into some word problems. All right. Okay. So we're going to set up a proportion. We're going to practice setting it up. Okay. So I have this, this tree. All right. It's a beautiful looking tree. And then I've got, and I'm going to tell you that tree is X feet tall. So we actually don't know how tall the tree is. Okay, so since we don't know, we're going to say it's X feet tall. But I have this man right here. Okay, so he's got, I didn't draw him, but he's a good looking guy there. Okay, so we got this man. All right, so we do know that he's 6 feet tall. I know he doesn't look 6 feet tall, but he's 6 feet tall, which means this tree has got to be definitely taller than 6 feet. Okay. So what we're going to do is we're going to set up a proportion to figure out how tall this tree is. Okay. Now, to be able to do that, we actually need the sun in the sky. And I know that looks like an egg, like a fried egg, but it's actually the sun in the sky. Okay. So if the sun is out, that's going to help us. And the reason that it's going to help us is because that sun is going to cast a shadow of the tree. Okay. So we're not able to climb the tree. And even if we could climb the tree, we can't really measure it because that would, like, are we going to climb out on the branches? We can't really do that. So, but what we can do is we can measure the shadow of the tree. So this tree is casting a shadow. So that shadow is 25 feet long. That doesn't mean the tree is 25 feet long. It just means the shadow is 25 feet long. We don't know how tall the tree is yet. Now, we also need to know what the shadow, how long the shadow is of this man over here. And that shadow of him is 5 feet. So the shadow's 5 feet, but he's 6 feet tall. And the shadow of the tree is 25 feet, but we don't know how tall. So we're going to set up the proportion here. Okay, so there's a few different ways we can do this. So I'm gonna give you part of the proportion, and then you see if you can figure out the second part of it. Okay, so here's an example, a correct proportion. Okay, so my little note is you make sure that you match category for category. Okay, so they've got to be matching categories when you're setting up the proportions. Okay, so make sure you match category for category. Okay, so here we go. So if I told you that if the first ratio was x to 25, x to 25, right? That's how we read that, x to 25. What would be a matching ratio or a matching that would make the proportion correct? If I'm going the height of the tree compared to the length of its shadow, then what would we want? You get it? If I go the height of the tree compared to its shadow, then we want the height of the man compared to his shadow. And so our correct proportion would be 6/5. Okay. All right, let's try another one. We can do it a different way. So we could set this up. We could do leapfrog, and then we could figure out how tall the tree is, right? Okay, but let's try it another way. Let's see if we could do another one. What if I told you, if I gave you the height of the tree compared to the height of the man? So I'm going tree to man. So then what would be the correct proportion? If I'm going tree to man, then I would want to go the shadow of the tree to the shadow of the man, right? So I'd want to go 25 to 5. Okay, so if I'm doing the tree, this is the tree, that's X, compared to the height of the man, that's my 6. So if I went tree to man, then I want to go tree to man, the shadow of the tree, the shadow of the man, okay? All right, and I don't know why I don't have an equal sign there. I should have an equal sign. It'll probably pop up in a moment. Whoops. Okay, so if I go 6 to 5, so height of the man to his shadow, then that would be the same as the height of the tree to the length of its shadow, right? The height of the man compared to his shadow, the height of the tree compared to its shadow. Okay, and then I think I've got one more. If we go 6 compared to X, so the man compared to the tree, then we would go the man's shadow compared to the tree's shadow. So it'd be 5/25. And oh, there's my equal signs. I don't know why they were coming in late. Okay, so there's our proportions. Okay, so there's 4 different ways that we could set this up. And in each of those, we could figure out what X represents. So here, this one would be a little harder to leapfrog. Over here, this one would be, well, we could leapfrog down here, right? We could go 5 times 5. Whoops, we could go 5 times 5, and then we could go 6 times 5 and give us 30, right? And then this one would be hard to leapfrog, but over here we could go reverse. We could go 5 times 25, and then 6 times 5 would give us 30. So we could figure out the height of the tree is 30. Okay, all right, we got 2 word problems. I know this lesson's going a little long. 2 word problems, and then you've got a few homework problems on your own. Okay, all right, so let's set up our proportion. We want to set up a correct proportion. So the problem says, if it takes 6 cups of flour to make 54 cookies, okay, so 6 cups of flour to make 54 cookies. How many cookies can be made with 10 cups? Okay, so the first thing you have to think about is, what are your categories? So the categories, so we want to figure out, what we want to first figure out is what are we trying to figure out? We're trying to figure out the number of cookies. Okay, so how many cookies can be made with 10 cups? So we're trying to figure out how many cookies. So that's what we want as our X. Now we have to figure out, well, what categories are we working with? So we're working with cups and cookies, right? So cups and cookies. So we have a ratio. It takes 6 cups to make 54 cookies. So we first want to do 6 to 54. Okay, and then it says how many cookies can be made with 10 cups. So where are we going to put that 10? That's what we got to think about. Is the 10 going to go upstairs or downstairs? Well, since it's 10 cups, we want that 10 upstairs, which means we'll have an X downstairs. Okay, so now, can we leapfrog this? Well, not really. Is 6 times a number makes 10? That's a little tricky. Okay, so we're going to have to cross multiply. So let's cross multiply. So I'm going to go 6 times X is 6X. And then 54 times 10 is 540. Now I can divide by 6. And how many times does 6 go into 54? 9. And then we've got the 0. So X is equal to 90. Okay, so with 10 cups, we can make 90 cookies. 90 cookies can be made with 10 cups. Okay, 10 cups of flour. All right, so we just set up a proportion. At the beginning of the problem, we had no idea. Let's backtrack here. Let's see if I can backtrack. So at the beginning of the problem, we had no idea how many cookies could be made with 10 cups, but we set up a proportion. So we wanted to figure out the number of cookies. So our 2 categories were cups and cookies. And then we went 6 to 54. And that we know that there were 10 cups. So we're going to figure out how many cookies can we make. We did a cross multiply. And then we divided by 6. And we figured out that it was 90 cookies. Okay? All right, one more word problem in this lesson. A factory can produce 91 widgets in 7 hours. How many widgets can it produce in 12 hours? Okay, I don't even know what a widget is, but it doesn't really matter. It's just kind of a funny word. Okay, so we've got a factory. Here's our factory, and it can make 91 widgets in 7 hours. We want to figure out how many widgets can it produce in 12 hours. Okay, so we want to figure out how many widgets. So the number of widgets, that's what our X is representing. We want to figure out how many widgets. Okay, so we're going to set up our categories. We've got widgets and hours, and then let's set up our first ratio. So 91 to 7. So 91 to 7. And then we've got this number 12, so that's hours. So we want 12 downstairs here, and then we'll put our X upstairs. So it's going to look like that. Okay, now, can we leapfrog? Well, not really. 7 times a number makes 12. We can't really leapfrog that. So we're going to have to cross multiply. So if I go 91 times 12, and it doesn't matter which way you go. You go this way first or this way. It doesn't matter. So 91 times 12, if you have your calculator, that's going to come out to 1,092. Okay, and then I've got 7x. So now what am I going to do? I'm going to divide by 7. And when we divide by 7, we find out that in 12 hours, right, we're trying to figure out how many widgets. In 12 hours, the factory can make 156 widgets. 156 widgets. Okay. All right. So that's the end of the lesson, the PowerPoint lesson. You do have some homework assignments, or you have some homework problems, not assignments, homework problems that are also in your notes packet. So I'm going to flip over and let you look at that for a second. Let me see if my camera is working. Uh-oh, my camera's not working. Let's see. Let's try this. Come on, camera. No. One more time. Let me try it one more time. There it is. Okay. All right. So you have proportions practice number 1. This is in your notes. So the directions say solve each proportion, find the solution for the variable, show all calculations in order to receive full credit. Okay. So on this one, you would want to see, okay, can we leapfrog this? Okay. Well, we probably can, right? I can go 4 to 8. So I can go 4 to 8. So what did I do to get there? Well, I multiplied by 2, right? So then I can leapfrog up here, and I can do the same thing times 2, and then 2 times 2 is going to make 4 right there. So y would be equal to 4. Okay, so you can leapfrog that. That's fine. Okay, but make sure you show all of your work. If you're going to use the leapfrog method, you better show me with an arrow and what you're multiplying by. If you don't have that work, then I'm not going to give you credit. Just because you can do it in your head doesn't mean I'm going to give you credit. Okay, so you've got to show me your work. Now you're going to get to some problems where you're not going to be able to leapfrog it. So for example, down here on this one, we can't really leapfrog this, right? 10 times what makes 25? That's going to be a little harder to leapfrog. So you're going to have to cross multiply. Okay. All right. So that is your lesson. You have 7 problems, homework problems that I didn't walk you through. Make sure you have all of your notes filled in correctly, and I will see you in class. I know this is a little bit longer today. Okay, I'll see you in class. All right, bye.